characteristics of the hyperbola. A hyperbola looks sort of two middle parabolas, with the two halves being called branches. The hyperbola is centered on a point h, k, which is the center of the hyperbola. The point on each branch closest to the center is the branch called vertex. The vertices are some fixed distance a from the center. The line going from the one vertex through the center and ending at the other vertex is called the transverse axis.
The foci, plural focus of an hyperbola, are inside each branch, and each focus is located some fixed distance c from the center. This means that a is less than c for hyperbolas. The values of a and c will vary from one hyperbola to another, but they will be fixed values for any given hyperbola. For hyperbolas where a is less than c, the relationship is c squared minus a squared equals b squared, or, which means the same thing, c squared equals b squared plus a squared.
Consequences and implications. The hyperbolic shape has mostly positive effects when used in architecture and manufacturing. As one of its characteristics, it's that it provides strength and stability. Both elements are needed in the man-made decoration.
Applications of the hyperbola in the modern world include, in architecture, Dulles Airport, located in Virginia, United States, and designed by Eero Saarinen. It has the shape of a hyperbolic paraboloid, a three-dimensional curve that is both a hyperbola in one cross-section and parabola in another cross-section. Another application is the cooling towers of nuclear reactors and coal-fired power plants. These must withstand high winds and built with as little material as possible. The hyperbolic form solves these problems. This shape requires less material than any other shape.
The saddle shape allows for easier stacking of chips. This also minimizes the possibility of broken chips during transport. A hyperbolic paraboloid is an infinite surface in three dimensions with hyperbolic and parabolic cross-sections.
Conclude that hyperbolas are used in modern world for supplying architecture and other fields with stability and thus being able to withstand hard cities. We can also conclude that hyperbolas are found everywhere, not only in constructions or difficult signatures such as math. Hyperbolas are also found in commercial products, attractions, and even fabrics.